Okay, let's see. Before I guess we get started today, let's go over here to Stream and we'll talk about the announcement I put in to Google Classroom. Okay. Came down this weekend, today, whatever. It came down to us today that we are supposed to start marking students virtual present when we have those distance learning days. So you guys, if you're on the A schedule, then on Tuesday and Thursday, you have to demonstrate to me in some fashion that you were actually quote unquote in class, and to get marked present. If I don't have any evidence that you were in class, then I have to mark you virtual. I have to mark you absent. That makes sense? So, since I've told you guys from the first day that this class period is your class period, even if you're at home, the expectation is if there's an assignment that's classwork, you need to turn it in during this class period or by the end of the class period. That makes sense? Homework's still homework, okay? This is the first day we're doing this, and students in the B schedule, there weren't any assignments that were assigned as classwork for that day, so I don't know. I just mark everybody present just because I didn't have anything given to them on Friday to do that, okay? But this is something new starting this week. Just so you know that if I assign classwork, it needs to be turned into this class period. Now, if you have a problem, if there's some kind of, difficulty, your mother's in the hospital, I don't know, make sure you use Remind and text me so that I don't mark you absent. That makes sense? Okay? I will, and as long as in a situation like that where you've got you didn't just sleep late, but you got a problem that actually came up, then as long as you get your work done that day, I can still go back and change that to being present. That makes sense? But we don't want to make a habit of it, all right? So I want to try to get you guys to be in the habit of knowing that this class time is your class time, whether you're home or at school, right? So then Fridays are that virtual learning day, okay? So we are actually going to have a virtual class. Everybody in the class meets on that day while we're on this hybrid schedule. And so according to my understanding of the requirements that came down from the Department of Education, if you're not in that virtual class, then I'm supposed to mark you absent. Now, there's a way to get on that virtual class even if your internet's down. You can get on your cell phone, your smartphone, and dial in on your phone, okay? So if that's, if you'll just, again, text me using the Remind system, I'll make sure everything's worked out for you, okay? But we just need to get everybody there for those virtual classes. So last Friday was kind of the shakedown for all that. Now that we're kind of up to speed, we want to, hopefully we're more up to speed, and we're going to try to get everybody where they need to be, okay? If you have a problem, just, if you'll let me know, I'll try to work it out with you. That make sense? Okay? All right. We're not going to try to make this unnecessarily harsh, but at the same time, it is school. All right, even if we have a pandemic and we have to do this distance learning stuff, it is what it is. Okay, so if you go to the classwork section in about 2 minutes, your safety test is going to pop up on here. All right? Yes? What now? I can't quite understand what you're saying. Can you pull the mask up or something? Just Yeah, you need to do lunch orders too during this period. Always do the lunch orders, okay? You don't have to wait till the beginning of the class period. You can do it before class starts, because I put that link on your Google Classroom. Okay, there's a link in there, and if I were you, I'd bookmark that so you've always got it. It's easy to get to and things like that. Okay, all right. So your test's going to pop up on there. So when it pops up, then we'll be ready to take the safety test. Now the safety test shouldn't take the whole class period, probably half an hour. Okay, sometimes people take a little longer than that. We are not going to take the whole class period to do this test, okay? And then when we finish the test, and when you finish the test, if you finish in 20 minutes and everybody else is going to take the whole 30 minutes or whatever, your after test assignment is to go to the, this will pop up on your computer. Actually, I put it in there for tomorrow. I need to put it in for today. Let me fix that right now. Let's see here. I inadvertently put the wrong day on there, so I'm glad I noticed that. So we're going to make it for 32 a.m. and it'll pop up on your computer in just a bit. Okay? Does that make sense? All right, so that's going to pop up on your computer now. Let's see, it's scheduled for 8:32, so it'll pop up. I'm going to show it to you now because this is what you're supposed to do after you finish the test. That makes sense? Now, we'll spend the class period going over this, but I just kind of want to tell you what's going to go on. This is a lab, but because we can't do labs face-to-face, I've sort of rewritten and reworked this lab to try and give you as much of the lab experience as possible while also having to do that lab work at home. So most of the lab work you can do during this class period, or you can do at home, okay? And then there's some assignments that have to be done before I give you the data you need for your lab. So I'll show you here. This document right here is where you're going to use your lab logbook. You're going to write out a set of procedures based on the description. But you guys are deciding on what your procedures are going to be. Okay, and once everybody finishes the test, I'm going to give you some time to talk about it. Okay, you can't get up and walk around the classroom, but you can talk from your desk, okay, about what you think might need to be done. That makes sense? Okay, we're a small enough class that we'll make this whole class one lab group. All right, so in a larger class, I'll let people kind of have some freedom to decide what their lab group is. If you want to work individually, you can, but you can also work together. Also, you can meet virtually to work on this stuff if you want to talk together. You cannot meet face to face. Does that make sense? Okay. So when you get your set of procedures done in your lab logbook, you're gonna write your procedures for this lab. You're gonna brainstorm. Okay. What do I think would work to do what needs to be accomplished? And the description is here on what you're trying to do. You're going to write a set of procedures, and you're going to do that thing with Cam Scanner and Google Drive and copy and paste and that sort of thing and put it in there, okay? This video here describes significant figures as it applies to, actually I need to put in there another video which describes this lab too, and I haven't done that. I'll get that done. It's in, let me think now. No, I want you, yeah, it's in the other assignment. Once you turn in your procedures, then I can give you access to the data. Does that make sense? And it's also in Google Classroom. So you won't be able to see it today until I put your name in for that. But once you turn in your procedures, then I'll make this accessible to you. Does that make sense? If you get it done during class, then I can do it during class. But if you turn it in later, then it depends on where I am and how much, if I'm available. I might be eating supper or something when you turn it in. It might be a little while before I can get to it, or you might turn it in at 9 o'clock at night, and I don't check my emails and things like that at 9 o'clock at night. Does that make sense to everybody? Okay. So when you finish the test, start carefully reading through this about what it's asking you to do, and you're going to write procedures and put those in the lab logbook and post them there. I would watch this presentation here because this pretty much describes what you're trying to get done. Does that make sense? Okay. And then, okay, so we should be ready to take that test for you guys. You guys ready? All right, then you can. What I want you to do is to do the test and then start reading. And once everybody's done with the test, you guys need to let me know when you're done with the test. It's all on here. There's no paper version part of this test. There will be in future tests, but it's all multiple choice and you click choices in the test. And then once you're done, just let me know. And then when everybody's done, then we'll start talking more about the lab. That make sense? All right. Okay. I just got a new email about the attendance policy. The new attendance policy. Just so you know, they're telling us now that not to worry about the new attendance policy for a few days until we have a chance to have a teacher meeting. That makes sense? The earlier email said we're supposed to put it into practice today. Well, now we're saying we'll wait a few days before we put it into practice. But at least you know it's coming up. Got it? All right. All right. Okay, so if you open up your Gmail, and
Join a meeting?
well, you can.
Start a meeting?
This is where you, if you want to start a new meeting, but you'll have to share that meeting information with somebody, with other people in the class, for example, if you wanted to have a meeting with other people in the class. Does that make sense?
Mm-hmm.
You just need to send it to their Gmail account. Okay.
Press start a meeting.
Yeah, just click new meeting. Okay, and Meet will pop up on your screen. I'm not sure why this is showing. There we go. So now you have something to share. You can share people this link right here with people, so you can send that out by email to anybody else in a group you want to work with. If you want to study or do homework together, you can just start your own Google Meet. That make sense? Yeah.
Yes.
So what I want you to do is email that link that you have open to me. Okay? Email that link you have open to me. Okay? Copy it and email it to me. So if you're emailing something to me, if you just type in the word Tedder in the address bar, my name should pop up there. Okay? But the syllabus has my email address on there. I don't need this on right now. You've got emails. You may have emails from me in your email already. Okay, I'm waiting on this to pop up here. See if I can find it. You sent the email to tedderar@spark6.org.
Yes, sir.
Okay, it's just taking a minute for it to come through. All right, so here's the email link that I was sent. Okay, everything okay?
Sorry.
Everything okay?
Yeah.
All right.
Figuring it
And if
out.
I just click that link, then it's going to open up a Meet that you set up. So it's your Meet, you're in charge of it, but that we can actually work together on projects. Again, this lab you're doing tomorrow, you don't have to do it that way, but if you guys want to, you want to collaborate on a lab, okay, that's it's there for you. They provide that information, that service to you it became a full Google School as of this year. So it may take a minute for it to pop up here, but at home it'll probably come up a little bit faster. Okay, and so you can do a meeting like that. Does that make sense? Okay, so before you leave today, if you guys want to collaborate on the lab, make sure you share email addresses. Okay, I usually have students put it in their lab logbook because that's where you're going to be working anyway. Okay, I was hoping it would pop up so you can kind of see. Ready to join, but it's not giving me the join button here yet. Maybe it will. Oh, I know. It can't do it because I'm using the camera over here. So it can't do the camera twice. Okay. But that's how you do it. That's how you start it up. Okay. So you can start your own Google Meet. If we're having a class-wide Google Meet, use the link that's in Google Classroom. Okay. That makes sense?
How do I set up that cam scanner app?
You don't have to set it up. Did you download it?
Yes, sir.
Okay, then you just open it up. Start using it. But the video shows you how to do all that.
Okay.
Okay? If I have time in class today, I'll show you. What I want to do right now is to go to the lab that we're going to try to do. Here, let's see, that's not really, yeah, we'll go to this one. All right. All right. So what you guys need to do is to read all this description in here. Okay, this is like reading the instructions. Okay, And then it tells you in here you're going to develop a set of procedures. You're going to propose a set of procedures that will accomplish the goal of this lab. That makes sense? Okay. That doesn't mean that you're going to have the right procedures or that your procedures won't work. But that's the way science works. In the sciences, we design experiments all the time, and when we get into it, we find, oh, there's a problem here. We got to revise things. And so all this stuff with COVID-19, where they thought in the beginning that it worked like this, and now they're finding out there's all these new things and things change over time. You're seeing science unfold in real time with this COVID-19 pandemic because they're having to revise things as time goes along. You don't get it right from the beginning. So science is always revising stuff. It's just the way things work. And that's what I want you to practice with this lab, is you're going to propose a set of procedures that probably won't work, but it's a place to start. Does that make sense? So when you send in on this document, so this is the document that has your name on it, and it'll open up here. It's a little slow here this morning. Well, it's slow anyway because I got all these people with all these computers on right now. But you'll, using that CAM scanner app, okay, you're going to take a picture of the equipment you think you're going to need and the procedures you think you're going to use, or maybe more than one. You're going to scan it with your CAM scanner app. You're going to upload it to Google Drive. You're going to, from here, then, you're going to insert those pages into here, okay? Once you send that to me, then I will open up for you the data you're actually going to use for the lab, okay? You won't actually be able to go in the lab face-to-face and work with things. I have a video that explains how it all works, but you can't actually do it in the lab. That makes sense? Okay? So I've showed you this once before, but just to make sure everybody's clear, has everybody opened up this document already? Your reporting document, saltwater lab procedures and equipment list.
Do we click on that?
Yeah, open it up, and that's yours. It's got your name on it. You know, you can edit it in it. Yours will have your name on the front end of it. Okay? And what I want to do is to put my cursor in here like this. Just click below what's here, or you might have to click at the end of that sentence and hit return. And then once you've uploaded your scanned images to Google Drive, you click Insert, Image, and click Drive, and your documents that you've uploaded will appear over here on the right-hand side. The most recent things will appear right there. Okay, so it's really easy to put that into your report. Does that make sense? Okay. All right, so I've shown you that before. I'm not going to spend a lot of time with that, but once you turn that into me, then I can give you your data for actually doing the lab. So let's look at, you don't have to open this up, but I'll put this on here so you can go back and look at it if you want to. I'm going to show you the slide presentation. We're going to walk you through what we're going to be doing in this lab and what the goal of this lab is and how it's going to work, okay? So when you open up Google Slides, in order for you to see how it's supposed to look on the screen, you press Present. Okay. All right. So this is the saltwater density lab report we're talking about here. This is the lab we're doing. So in this scenario, students will be chemical oceanographers. So there's a scenario for this lab. We're trying to do this lab as much as possible as if you were actual scientists, okay? Trying to get you to the point where you kind of think more like a scientist. One of the most important goals we have in a science class is to help you develop the way to think, the way a scientist thinks. So the goal of this research, if you want to know what an oceanographer or chemical oceanographer is, you can click right there and they explain that for you, okay? The goal of this lab research, each group needs to determine the concentration of salt in a sample taken from an estuary. Well, an estuary is just a place where water is just inshore from the ocean. All right? So like where a river flows in, or creeks flow into the ocean. that area right there is called an estuary. It's a mixture of unsalted water and salted water. Okay, that's all that means. So your goal then is to determine the concentration of salt in a sample from the estuary. And the estuary is the tidal mouth of a large river where the tide meets the stream. Individual students will brainstorm for themselves and then as a group the procedures that might be used for figuring out how adding different amounts of salt to water could affect the density of each solution. That's going to become the basis for creating what I talked about last week was something called a standard curve. And that video y'all started to look at a while ago was about what a standard curve is. Okay, so we're going to be creating our own saltwater solutions of different concentration, and we're going to make a standard curve against which then you will compare that sample from the estuary, and we'll call that the unknown. So step one is to figure out how to make solutions with different amounts of salt. Part of this first goal is to figure out how to make the solutions with different amounts of salt while keeping the volume of each solution the same. That's the tricky part. Okay? Now, I don't expect you to get it right. I want you to do the best you can. Okay? Because that's what scientists do. We try it out. If it doesn't work, we try something else sometimes. The amounts of salt in each solution should be recorded in your student lab book. Remember, you only write in pen, black or blue pen in your lab log book. Okay? You got to number each page. You got to put a date on it, any new thing you're doing. The amount of solution is supposed to be the same. So you got 10 solutions with different amounts of salt, but the solution volume is the same. Now, a solution is both what you're dissolving and what does the dissolving. Okay? So the salt is being dissolved in water. Together, the salt and water make up the solution. All right? That makes sense? Okay. So you drink a glass of tea, you've got tea dissolved in water. If you got sweet tea, you've got sugar dissolved in there too. So that's a solution. Each solution should be measured in those ways needed to determine density. Y'all know what measurements need to be done to determine density? Huh? Milliliters. Well, any volume, but milliliters is one we commonly use, yeah? That's one of the two things you got to measure to determine density. Huh? Okay, the other thing is you got to measure mass. Usually we measure it in grams. That's not always true, but most of the time in here we're going to measure it in grams. So you have to measure grams of the solution. So you got two different mass measurements. You got the mass of a salt in each of these samples, and then later after you dissolve the salt, you get the mass of the solution, and you got the volume of the solution. The mass of the solution divided by the volume of the solution will give you the density of the solution. Okay? Each solution should be measured in those ways to determine density, and they should be recorded in your lab log book. That make sense? Everything's going to be recorded in your lab log book. All right. Then I just put in some graphics here to try to help you understand. So I don't have 10 different solutions here, but I've got 6 here. Okay. So 6 samples of salt, but we're going to have the same volume of solution. The trick for you guys is to figure out each time how to get the same volume. Now, this illustrates the fact that we have 40 milliliters, but you might choose some different amount. The one thing you don't want to do is to have an amount that goes all the way up to the very top marking, because sometimes it's hard then to actually figure out that you're right at that marking. Okay, you really should stay below that top marking. Salt, water combined should have the same volume each time, and that's the tricky part. Okay, and then once you find the volume, then you can find the density of each of those. Okay, and you divide the mass by the volume to get density. Make sense? All right. Then you got to produce a graph with that data. You're going to have mass of the table salt. Okay, let's go back to that previous slide. The mass of the table salt goes on the horizontal axis. That's what you changed. You kept the volume constant. That's a controlled variable. All right? That's why we keep the volume the same, because you need to control that variable. That gives you an idea, some practical experience with what a controlled variable is. It could be a variable because you could change the volume, but we don't want to do that, okay? And so you're going to graph that data, and you're going to produce a best fit line. And we went over, how to use, let's see, we're using Veneer graphical analysis now to do all that, okay? Well, this best fit line now is your standard curve. That's what we're going to compare the estuary water against. You're going to determine the density of the estuary water. It doesn't matter how much you start with, as long as you know the mass and volume, okay, and we'll determine what that is. Now, you'll place the mass of the salt in each solution on the horizontal axis. We're going to label it down here. We talked about how to do that, okay? And then the density is going to go over here. And so independent variables is the one you change. That always goes on the horizontal axis. Dependent variables, that we change the density by changing the amount of salt. That's the dependent variable. That always goes on the vertical axis, okay? And the title also implies what the independent and dependent variables are. I taught you how to write a title, okay? The effect of, give me the independent variable on the dependent variable, okay? That's what I've described right here for you. And then the next step is to use the measurements and calculations above to create a dot graph. We talked about that. This is your, I've already said that. This is your standard curve. It's also called a calibration curve. Actually, this would be a standard curve. You used to do the same thing for a calibration curve, but I just want you to know it's done the same way, okay? Technically, this is a standard curve and not a calibration curve. All graphs, when you're doing experiments like this, should be a dot graph. You never do bar graphs when you're doing experiments, okay? Then you're going to be given, and I'm going to give you this. It's on the data sheet I'm going to give you. A sample of estuary water, you'll determine its density by determining its mass and its volume and dividing. And then you're going to compare that against the standard curve. So the way that works is that'll be your analysis, and you'll write that in the conclusions. The way that's going to, let me see how I got that in here. Yeah, here we go. So if the density, and this is just an example, so your estuary water won't have this density, but you find whatever the density is, find where that value on the density side, the vertical axis, intersects with the standard curve, and then you find out by going down from this point where it intersects, you can find out the mass of table salt in that same volume of water for the estuary. That's your goal. That's your ultimate goal for your analysis. That makes sense? Okay. So, has anybody here taken the ACT already? When you take the ACT, there's a whole science section, and the vast majority of those questions are about graphs. And a lot of them are about stuff just like this. How do you use a graph to figure out an unknown? Okay, and that's what we're doing here. That makes sense? All right. Normally we actually making these solutions in the lab. We can't do that because of the protocols for safety during the pandemic. Okay, so the intersection here tells you the concentration of salt in the unknown, and that will be the basis of your analysis. So you'll develop procedures. You'll gather data in class if we're doing a lab in class. You got to understand what density is. It's important to be able to put together a formal table and graph. We've already talked about that. There's also videos on here and documents on here to explain what a formal table and graph is. If you need some help with that, go back and look at that. Since we're doing it virtually, you'll be providing me a summary of procedures, and then I'll give you graph data or data from that was gathered in a lab for you to use for your graph. Okay, so the part that you won't be able to do to get this full experience is the part where you actually go to the lab and start mixing things together. Okay, everything else you can do for this lab. You still get most of the same experiences. Okay, and you understand. So hopefully, when you're done with this, you'll have a better understanding of what a standard curve is and how it's used. The normal procedure is for students to meet face-to-face, and I showed you how to do a virtual meeting. So if you guys want to do that, and while you're in the classroom, you can talk to each other. We got maybe 20 minutes or 15 minutes left in class for you to be able to talk about that. Safety protocols, we can't do that. Virtually means you're going to, you never, do not, please, do not meet face to face, okay? I'm allowing you to work virtually, but don't set up a meeting, at Barnes and Noble or something, okay? Or Zaxby's or whatever. Let's see, I think all that is covered already. You're going to create the calibration curve, 10 different concentration samples. I'm going to give you those. You'll decide what equipment and procedures to do, that you'll turn that in, then I'll give you your data. Okay? You don't really need that, but if we were doing the lab, I would expect you to start doing the procedures you proposed and find out in person that it doesn't work, and then go to something else. Okay? So that's behaving and doing things the way a scientist would do it. The research report is going to be submitted on Google Classroom. You'll get that research report when I also send you your data. Okay, when I give you access to it in Google Classroom. You don't have to worry about the lab officer report. We talked about scanning and uploading and pasting your lab logbook pages where you have the procedures. You have the procedures and the equipment list on there. You don't have to know exactly what the equipment is named. If you can't figure it out, make sure that you give me your best description of it. Okay. All right. Usually we spend 3 or 4 days on this lab, but since we're not doing the in-lab part, which takes a lot of time, then you have today and tonight for the homework and tomorrow to do this lab. That makes sense? Okay. For some reason it wants to stick on me here. Why is it doing that? Anybody have any questions before you get started brainstorming? All right, you get started. Why don't you leave in your lab logbook, since you're new. We only write on the right-hand side pages. So, like, flip over about 4 pages before you start on this lab, okay? Got it?
Yes.
Sort of. I know it's all kind of like, because it's all new stuff for you. I get that. But do what you can, okay? You can talk to these guys, okay? Everybody good? Questions? All right, go for it.